Yeah, so while preparing, let me introduce Francesc, and he will now go to the topic of the data compression. He's the CEO of Iron Array, and he is in this business for quite some time already, and also he will specifically talk about how this compression works together with HDF5.
And then okay. Seamless integration of Blosc2 and HDF5 for high performance data compression. So I will first do some small introduction to what Blosc is. And I will say a few words about the plan that we made for HUG25. And then I will finish with some words on the node of HUG25, which is meant for on-demand access to local and remote Blosc2 and HDF5 data repository. Okay, so a quick introduction to Blosc. Blosc is essentially a collection of products, but also filters that are meant for compression binary data, okay, which is also the field of HDF5. And the goal is sending data from memory to CPU faster. And you can achieve that if the data that is being compressed, this is stored in memory and it takes much less bandwidth to compress, right? So this saving bandwidth, if your CPU is fast enough, maybe the compression time and especially the compression time can balance everything. So that's the idea. You can Blosc. And 2 years ago, we introduced Blosc2. Blosc2 addresses some shortcomings of Blosc. So Blosc2 adds 63 full 63 containers. It allows also meta layers. Meta layers, okay, for storing meta information for the user, and all the data is here. And then we are introducing also a two-level partition. So most of the storage only has one level of partitioning, so called the chunks. Is that, but at the same time, we allow every chunk to be split in what we call flow. And this will have important consequences for accessing that. A few words about Iron Array. We are the developers of Pytable, Next, the Blosc ecosystems, and we are a team of experts empowering you to have the potential for doing that. Okay, so let's start with the support for Blosc2 and inside of HDF5. And this was work done in the framework of the program that ended in the last one. So as a consequence of this work, we released a new version of the Blosc2 plugin for HDF5. And I mean, it's just a compression plugin for HDF5 standard pipeline, and it has been integrated with HDF5 plugin. So here, as in HDF5 plugin, will be able to access plugin. And in addition, we did some optimization for Blosc2 and which is useful for selective reading of logs in data. We will see that later. So thanks to Ivan Milata and Thomas Vincent for their help implementing that. So the idea of leveraging the second partition is that, contrarily to typical chunk containers like HDF5 or DAR or others that only have one level of partitioning, in Blosc2 we have two levels. So in case we're interested in getting just a thin slice of the data, this better view, we don't need to fetch the whole chunks. We just need to fetch the small amount of blocks that are meant to be the gist of the two partitions. for much more selective and hence faster query. We also implemented HUG25, which is a way to use Blosc2 inside direct chunking and HDF5. So what this allows is that both compression and decompression can be executed in parallel, right? So we have here the Blosc2 libraries. Whenever we need to compress a chunk, like a HDF5, and we can compress that in parallel in Blosc2 because it's right? Works in parallel. And then we use HDF5 right chunk in order to store that in HDF5. And for reading, we are leveraging also the reading capability, the parallel reading capability of Blosc. Right? So the data can be read inside of a chunk, can be read in parallel. Okay? And once it arrives here, it can be decompressed also in parallel. And this essentially is a multi-path or HDF5, so the API is exactly the same. And I think is that if you import into HDF5, you will get access to it. Okay? In a completely transparent way. Of course, you will need to use Blosc to define it. Here we can see some benchmarks showing that when we are accessing different dimensions for a three-dimensional data set, for example, here we are representing actually a four-dimensional data set. Okay? But the idea is that you are accessing just very thin slices. And we are just demonstrating the capabilities of the two-level partition. We need to read less information. And we can see the acceleration, the throughput that we can achieve by using the direct chunking approach. Okay? We can achieve typically between a factor of 3 and a factor of 5 more speed than how the regular chunking mechanism. The HDF5 with the mechanism. You can read more in this workforce, where we explain how to the basement. And this optimization works for both our table and for HDF5 in field and V2HDF5. Okay. Yeah.
Is it better if we use that microphone?
Yes, way better.
Okay, so let's go for the next section of the presentation. So let's talk a little bit about the JPEG 2000 plugin that we implemented also in the framework of the libsimnov program for HDF5 and H5Pi as well. So most of you probably will know, but JPEG 2000, it's a codec that can achieve great image quality in relatively high compression, with relatively high compression ratios. It is a lossy codec, but the quality is so good that it is actually used in medical applications with good results. So what we did in this framework was implement a couple of codecs as Blosc2 plugins. So the same way that HDF5 has plugins, the concept of plugins, Blosc2 also has this concept, okay? So we implemented a couple of codecs with this Open HT J2K and Grok. And everyone, it's implementing the high throughput J2000. But one of them supports 16-bit gray images, whereas this one only supports 12-bit images, okay? So in general, Grok is supported, but in order to use them, you just have to install the wheels. Wheels are installed. You can read data in HDF5 straight if you have the HDF5 plugin. So the HDF5 plugin will call Blosc2, and Blosc2 will call this plugin. So it's a chain, okay, of two plugins. It works very, very well. And finally, I will introduce you to Caterva2, which is an on-demand access to local and remote Blosc2 and HDF5 datasets. My first intention was to show you an interactive demonstration, but apparently the setup is not ready for that. So what I did is I create some screenshots so that you can have an idea. Anyway, so Caterva2 is meant to serve data through internet. Essentially, this is the intention, okay? So in the backend, we can have HDF5 files or Blosc files as well, right? And then Caterva2 is just a server that exposes different interfaces, okay? One is the REST API, and on top of that, there is a Python API, okay? And then there is a web interface as well, a graphical user interface, which is based on the browser. That allows also to share data not only within your team, but also with the world, right? So we have 3 different folders, special folders in Caterva2, which personal is only for a registered user can access, then shared, where the whole team can access within read and write mode, and then there is public, where the whole world can access, but only in read-only mode, okay? So the interactive demonstration started here, but you can try going to cat2.cloud/demo, and there will be an interactive web service there, and you can follow the following explanation. You can also register to have write access in order to do some practice as well. Here there are some helpers. There is the script for creating HDF5 file in the demo. In this script, we created also files with JPEG codec, just for demonstration purposes. And then a Jupyter notebook for reproducing the interactive demo, the supposed interactive demo, but it's based entirely on the client API, okay, on the Python API. So everything that you can do interactively with the web service, you can do also on the Python API, or the REST API if you prefer. So this is the first screenshot that I quickly did a few minutes ago. So here we can see the interface. We have the prompt here, where you can introduce your own commands. Then a bar for the search, for searching the different data sets here, and then the different areas, okay? You can upload your own data sets by clicking on these icons here. And here we have already an HDF5 file already uploaded, okay? We have actually 2, and we are seeing this one here. And then below this one, this Kevlar Blosc2, we can see different data sets, right? So these data sets are actually the data sets in the HDF5 file. So they are just unfolded automatically for you, okay? And then the extension is always B2ND, meaning that this is a proxy. This is a Blosc proxy for the HDF5 file, okay? So, and we can see that the proxies takes very little space. It's just less than the 400 bytes, whereas the actual data set is 34 megabytes. And then when you click, we have 4 different data sets here. Every one is compressed with a different codec, okay? So Blosc LZ, LZ4, Z standard, and Grok. Grok is JPEG 2000. And you can display all the values. We have an integrated data viewer, okay, which is meant for the web. And you can scroll in different dimensions. We have 3 dimensions, and you can scroll in 3 dimensions. And you can browse it very quickly. Then there is the tab, which is called Meta, where we can see different meta information. for the proxy. And we can see the shape, the chunks, the blocks, the block shape as well, the codec, and the filters that has been used. And then this in VL meta, we can see that we have, this is an HDF5 proxy, and this is the original dataset name in the HDF5 file. And also we integrated visualizer for tomographies, okay? So this visualizer works for three-dimensional datasets that can be interpreted as tomographies. So in this case, when you click in the tomography tab, you can see the image. In principle, we should see a diffraction pattern here because this HDF5 file has been taken from X-ray diffractions. It got 10 frames, this subsample that I used. But we are not seeing a lot of diffraction pattern, right? But we are seeing still these white bands here, this grid, which means that we are seeing something, right? So the problem is that, as we can see, we have values that are like saturating the image, whereas most of the values that has content only have one. So there is a big difference between ones and this saturation value, right? So the idea is to equalize the values so that we can see something actually, right? So in order to do that, we can use the prompt here where we specify an operation on top of the data set, okay? So in this case, what we are going to do is for all the values in the data set that are less than 10, we replace these values by multiplying by the actual value by 20,000. And if not, then just the actual value, right? So this is actually what is called a lazy array. It is not evaluated on the fly in real time, but it is evaluated on a deferred basis. So once you define this, okay, it is here. It is actually a proxy, again. And when after this operation, and when we are displaying this proxy, okay, we actually see something here, right? We are seeing the diffraction pattern. It's because we equalized the values. So a lot of things are happening here. First, we are accessing the data straight on this HDF5 file. If the data is compressed with Blosc2, it will be handled to Blosc2. If the data is compressed with JPEG, will be handled to the JPEG codec, okay? It will go back and will be evaluated by the expression. Everything is going on the flight. So it's, I like it to show the interactive demonstration. It's very snappy process. It takes less than 1 second to see every frame. And with that, you can select the frames, okay? You can go, if it is 1,000 frames, you can go straight to the 1,000 and you can see it without any problem. Okay, so that is the end of the interactive demonstration. Caterva2 is free software. It comes under the provisions of Affero GPL, and you can find the code available here. We also started a beta program where if you join it, you can have the advantage of have access to developers. And you can provide usability hints. You can suggest plugins for that. It is extensible. You can put your own plugins in Cat2 Cloud, and it is free. So I encourage you to register as a beta users. Okay, so in conclusion, we have shown the progress in integrating Blosc2 with HDF5. The Blosc2 and Iron Array teams have been working hard at implementing native support for Blosc2 in HDF5. We have seen the plugins for the high throughput JPEG 2000, and I showed you the interface for Caterva2. So all in all, Blosc2 is a highly efficient and flexible tool for compressing your data your way because it supports a lot of plugins. In the future, we are really pleased to see the hierarchical structure of HDF5. So we are thinking in better integrating our software like Blosc and Caterva2 with HDF5, especially for, as I said, for this hierarchical structure. If anyone in the audience is interested in that, just talk after during the day. So lastly, thanks to donors and contracts that are allowed to do all this work, not only this one, but the previous work. Without them, we couldn't have possibly done Blosc. And thanks in the name of the Blosc2 developers and Iron Array as well. If you have some questions, I will be happy to take it. Thank you.
Thank you again. So if there is a question, yeah.
Yeah.
Yes, thank you for the presentation.
Mhm.
The expression that evaluates the values on fly and in Caterva are using any kind of language or
Yes.
Python, was that, or it's
It is, I mean, in the latest version of Blosc2, which is called, we labeled 3.0, we introduced a compute engine, a completely new compute engine, which is based behind the scenes on NumExp. Okay, so NumExp is a multi-threaded computational engine made for Python. So Blosc2 is using that in order to do computations with compressed data. So the advantage of the new computation engine in Blosc2 is that it can compute with compressed data. Everything is decompressed behind the scenes and recompressed again. Okay, but it's essentially using the Blosc2 computational engine introduced a few months ago.
so I could write Python expressions.
Python expressions, yes, you can essentially all the NumPy universal functions are supported.
Oh, okay. Thank you.
All of them.
Thank you very much.
Yeah.
Okay.
I don't know, just to make it clear, when Caterva2 between the backend and frontend is using like is transmitting compressed data.
Yes.
Yeah,
We always try to transfer always compressed data. Yes, and it will be decompressed on the client side.
yeah, and when you evaluate, you compress again.
Yes, exactly.
Okay, thanks.
Yeah, the idea is to save bandwidth as much as possible, which is the bottleneck when you are working through internet.
I have also one question to Caterva. So this you presented like a service which you provide in the cloud. Is there a concept to integrate that tool or that service to the existing scientific repository? So if we have a couple of petabytes of data that we could...
Exactly. So we are offering Caterva2 in Cat2 Cloud, like a cloud service, but of course, we also provide consulting for helping users to install Caterva2 in their own on premises.
Okay, thank you.
And regarding the interface, you mentioned that we can very easily jump to slide number 20,000 or something like this. And do you plan to have a kind of slider? So instead of typing the number in, I can just grab and move it right and left?
It can be done. I mean, we just, yes. So this tomography tab was just a plugin in Caterva2. It's just a matter of making the plugin a bit more intelligent and more adapted to the user needs.
And yet another question, it's about the legend. I imagine we haven't seen anything because we're just using a linear intensity legend, and that there were huge differences, so that's why everything was black. You haven't planned actually to make a kind of legend editor where we can simply choose a specific range on the viewer side, nothing to do actually on the server side, but just on the viewer side.
When you say the legend, what do you mean exactly?
It is a color schema.
A color schema, okay. So the question is if we have plans for like choosing the color schema, you mean?
Adjusting.
Yeah. No, well, we don't have plans, but the beta program, for example, is for that, for exchanging ideas with the users and trying to adapt to their needs.
And, and one can come up with plugins, as I understand.
Yes, exactly.
Okay, so maybe the last question.
Thanks for getting this opportunity. So when we touch the point of viewers, like there is now a very popular H5 web, for example, as an excellent web viewer. And can Caterva somehow be like connected to it?
I don't know. We haven't put any work on that. I've heard about H5 Web, but I never tried it. It's essentially a web viewer, right? Okay. Yeah, maybe it can be integrated or not. Well, I mean, Caterva 2 is mostly for presenting. It's a very thin layer on top of the data, right? So probably interacting with another service. I mean, we need to think about it. I mean, it's I never thought about that, actually.
Okay, so let's thank speaker again.
Okay, thank you.